Hi, class. I wanted to take a chance to go through a very important concept that we're going to be seeing a lot in the coming chapters, and that is a functional group. So a functional group is a characteristic group of an atom or atoms attached to a larger molecule that play a central role in the chemical properties, the chemical reactions that that molecule will participate in. Oftentimes, these functional groups are the central part of the molecule that are actually involved in the chemical reaction, and the other parts of the molecule kind of come along for a ride. So if you can identify the functional group or groups on a molecule, you can predict how it's going to interact with other molecules. So there are 12 functional groups we're going to be going over the course of the semester. I want to put them all in one place for you instead of scattered like we have in your book and your notes, so that you can always come back to this page if you start to get a little lost with the names and what they mean. So I'm going to pull up your handout here, and we're going to go through all 12 of these. I want to right now apologize for my handwriting. I'm using my laptop, and typically I have a stylus that goes with my laptop, but I am Tierney and I don't know where that is right now. So my finger is going to be my pen, which should be just fine, especially if you hear what I'm saying, but I apologize for my messy handwriting. So let's get started. An alkene is simply a carbon-carbon double bond. So the structure is going to look like this. Oh, let me get my pen going on here. There we go. All right, so we've got a carbon double bonded to a carbon. And we're going to be putting lines going off, and those can be any sort of, maybe any sort of atoms. They could be hydrogens, strings of carbons, but this is the part of the molecule that we are going to be identifying. And we're going to remember how our atoms bond within a molecule. So carbon is in group 4A, which means it bonds 4 times characteristically. So each of these carbons are going to have 2 atoms, at least 2 atoms coming off of each. All right, so basically this is a carbon-carbon double bond. Okay, an alkyne is kind of similar. Instead of a double bond, it's a triple bond. So we have 3 lines between each carbon. They're triple bonded. They share 6 electrons. And since they are already bonded 3 times, each carbon will only have a single bond coming off of it. So this is a carbon-carbon triple bond. Our last functional group that only involves carbons is called an aromatic group. Let me explain what we're about to draw, because this is the most complex of all the functional groups. This is called a benzene ring when it's by itself. Benzene ring. It's a ring of 6 carbons. And when this ring of 6 carbons is bonded to something else, now it's known as an aromatic functional group. But when it's just by itself, it's called a benzene ring. And the thing that we see, so if we were to draw a 6 carbon ring, it would look like this, right? We would have a hexagon. In this hexagon, we will draw 3 double bonds. What happens is every other bond is a double bond. So we have 3 double bonds. So let's draw those. 1, 2, 3. Now you could flip them and have the single bond and the double bonds exchanged. We'll kind of get into that when we learn about it more. We can also draw it as a more expanded view with our 6 carbons all drawn. And this will show the hydrogens, because what we see is every carbon is in the middle of a double bond and a single bond, right? So that means it's bonded 3 times. So each of these carbons will have 1 hydrogen coming off of it. So to draw my 6-carbon ring, I'm going to have 1 CH on the bottom, 1 CH on the top, and then 2 on either side. That's how I draw it. This is not going to be pretty. I am just going to warn you, limitations. All right. So if this is our single bond and this is our double bond right here, that means there's a double bond on the right, a single bond on the left, and then every other bond is a double bond and a single bond. This is not very pretty. I apologize, laptop and finger. There's a nicer picture of this if you just Google benzene ring. There should be a nice picture. There are 3 main ways that these are drawn. So we could draw it without our carbons and hydrogens represented, like I have first. If we want to see those hydrogens in action, we can draw this one. As you can tell, that's not the best way if you ask me. We can also draw this way with, once again, our hexagon. And instead of 3 double bonds, we draw a circle in the middle, because what we see is those double bonds, they don't have a single home. They actually kind of get shared by all 6 atoms. And so this shows us that, and it gives these benzene rings a lot of stability. Okay, so that's our most complex. Let's simplify it quite a bit. Our next functional group is an alcohol group, also known. So alcohols contain what's called a hydroxyl group. A hydroxyl group is simply a hydroxide that is covalently bonded to a carbon. So we've got a hydroxyl group is an oxygen with a hydrogen. An oxygen will always bond twice. So it has 2 single bonds, one to something else, typically a carbon, and one to a hydrogen. And then because oxygen is in group 6, it bonds twice, and the other 4 electrons are these 2 lone pairs. Let me draw those lone pairs bigger. So as we draw these structures, we have to remember how all of our atoms are nonmetals. They have characteristic bonding patterns, and we see that play out in all of our functional groups. Thiols are very similar to alcohol groups, but we substitute a sulfur for the oxygen because sulfurs are also in group 6A. So I have a sulfur bonded to a hydrogen. Because it has to bond twice, it's going to be bonded to something else, typically a carbon. And then it has 2 lone pairs. There isn't a special name for that. Thiols, we're not going to see a ton, but they do play a pretty important role in things like our hair. So we're going to be learning about that. Okay, our next structures are going to be centralized around an oxygen doing something interesting and interacting with carbon. So our next structure is called an ether. An ether is basically an oxygen plopped in the middle of some carbons. All right, so what do we expect to see? We're going to see an oxygen, and then oxygens bond twice. So 1 bond here, 1 bond here. All right. Now, oxygen, I drew in this linear fashion up here, but to be honest, let's talk about that structure because we're going to be looking at shapes a lot. What happens is because it has 2 bonds and 2 lone pairs, it's going to form a bent shape. So let's draw our ether in that characteristic bent shape that we would actually see with a carbonyl group. Excuse me, a hydroxyl group. We're about to get to carbonyl groups. So we see this bent structure. We just have an oxygen in the middle. That's what it looks like. Just 1 oxygen with 2 single bonds right in the middle of a molecule. All right. Ketones have an oxygen in the middle, but that oxygen is branched out from a carbon. So with this ether, this oxygen is going to be single bonded on either side, typically to a carbon. With the ketone, we're going to have this is called the carbonyl group. So ketones contain carbonyl groups, like alcohols contain hydroxyl groups. And what a carbonyl group is it's a carbon with a double bond to oxygen. All right, so we've got a carbon here, got a double bond, and it's to an oxygen. Now let's fill in everything. So this oxygen, it already has its 2 bonds, so it's just going to have 2 lone pairs on it. This carbon bonds 4 times, so it's got 2 with oxygen, and that's going to be double bonded to some other things. What we see is this is going to have a characteristic trigonal planar shape around it because of that double bond. A carboxylic acid is essentially one carbon that has both a carbonyl group and a hydroxyl group. Okay, so we have one carbon. It's got the carbonyl group, so we have a double bond to an O. That O, once again, is going to have 2 lone pairs. And then off the same carbon is going to be our hydroxyl group. We go back up, that's just an OH. All right, so O, then H, and that O will also have 2 lone pairs. And the carbon needs a 4th bond. All right, so this is called the carboxylic acid because this H will often be donated in a chemical reaction, which makes it an acid. This is represented a couple different ways that I'd like you to be aware of. Carboxylic acids can be drawn just simply as COOH. That's a very popular way of writing it. I've also seen people represent it as CO2H. So be aware, COOH, CO2H, that means a carboxylic acid. All right, let's talk about esters. Esters are very similar to carboxylic acids, except for the H is another carbon. So we have our, basically what it is it's a carbonyl plus a ketone, which is the O right in the middle. So we have our C double bonded to O, and then a single bond to an O, which is in the middle of a molecule. So basically the carboxylic acid, in the carboxylic acid, it's at the end of a molecule, and then when we see it in the middle, that's going to be the ester. So this this oxygen that's double bonded needs some lone pairs. So all of our oxygens, you'll notice, have 2 lone pairs. So if they're in the middle of a molecule, there's 2 single bonds. If they're coming off a molecule, there's 2 double bonds. So notice that carboxylic acids and esters are very similar. Okay, so that's all of our functional groups with oxygens. We have 2 more functional groups left, and these are both involving nitrogen. So amines are simply a nitrogen. If you see a nitrogen, you've got an amine. So let's talk about nitrogen and how it bonds. Nitrogen's in group 5A, which means it's 3 bonds away from 3 bonds away from its octet, its 8 valence electrons, and it has 1 lone pair. Now these 3 bonds, that can vary. It might be a carbon, it might be a hydrogen, you might have 1 carbon and 2 hydrogens. We're going to get into definitions of how to differentiate between the different types of amines, but basically if you see a nitrogen in an organic molecule, it's called an amine. Now, similar to an amine, and in fact containing an amine, is this guy right here. We've got an amine, and then we're going to add to it a ketone or a carbonyl group. We've got a carbonyl with an amine. So let's draw our carbonyl. That's the C double bonded to an O. All right. And then we've got a nitrogen coming off of that. That is an amide. Amides contain amines. And because it's just a simple change of one letter, I like to pronounce these words very different from each other so that we can hear the difference between them. Some people call them amides and amines, which sound like the exact same word to me. So I pronounce amide. So there's a lot of different pronunciations of an amide. I say it to differentiate from amine. Okay. Some people say amide. I think I've heard 5 different pronunciations of this word. So just so you know, there's no wrong way. All right, so let's complete our amide. We've got lone pairs on our oxygen, 2 of them, 1 lone pair on our nitrogen, and then that nitrogen's going to bond 3 times. 1 time is with our carbonyl group. That carbon needs 4 bonds, and then there's going to be 2 other things coming off that nitrogen. So these are all 12 of our functional groups. Oh, I want to add something to our ester group because there's other ways of writing the ester as well. Similar to the carboxylic acid, you might see it as a COO, okay, or a CO2 in the middle of a big string of carbon. So just to warrant, let me just put these in parentheses here. These are other ways of drawing. And apparently doesn't want my finger to draw that. Okay, here we go. So those are alternative ways of drawing what structure, the larger structure I have. So these are the 12 functional groups. It may seem very overwhelming right now because we've got our big long list of 12. What we're going to be doing is each chapter will function on just a few of these functional groups and we'll get to know them really well. All right, but this is just a large reference table, so you can kind of come back to this at any point when you need a refresher, when they start getting mixed up in your head. It's going to be useful to have on hand. Okay, I think that's all that I need from you for this assignment. I'm going to stop my share, and then I'm going to figure out how to stop recording. Here it is. So that's all for this video.